Okay, so now that we have learned mutations, we are going to apply mutations which cause genetic abnormalities and genetic disorders to family trees. And a family tree in biology is called a pedigree. So pedigrees are pretty easy to read. They have an organized system, so we're going to go through that. First, they show how a trait is passed from one generation to the next, and it doesn't have to just be a genetic disorder. It can be anything. You can also use them to figure out the genotypes of family members. Remember, that's like your code, which is like AA, for example. They can be carried on any of the chromosomes except for the sex chromosomes, which are called autosomes, or they can show something that's just carried on the sex chromosomes. And then remember that your number of chromosomes can vary. For humans, it's always going to be 46. So first things first, you'll see that in this example we have 3 squares and they're colored in. If they're colored in, that means they have the trait. If they're not colored in, they don't. So we go down here and we get a little bit more in depth about some things. First of all, you notice that in a pedigree, you have 2 shapes, a square and a circle. The squares are males, the circles are females. So how many males do we see in this pedigree? 1, 2, 3, 4, 5, 6. So there's 6 males, then we got 1, 2, 3, 4, 5, 6, 7 females. If there's a vertical line, if there's a horizontal line connecting a square and a circle, or even a circle and a circle, or a square and a square, that shows that they either have a union or that they are a couple. And, well, either way they're a couple, but if it's a male and a female, and there's a line coming down from that, this shows they're kids. So when you have brackets like this, and anything dropping down from the bracket is a kid that this person and this person had. So this one, and this one are the 3 kids. This is not a kid because this is a partner of the square. It's their mate, it's their companion. The same with this one. So these are not kids coming from the previous couple. So if they're shaded in, they have the trait. If they're not, they don't. If you ever see something like half shaded in, then that would mean that you don't have the trait, but you could pass it on to your kid, and that would look like this, for example. So you'll see that occasionally. No shading means you don't have the trait. So, and then if there's a diagonal line going through the shape, that means that they're dead. You'll also find the date of the death and the cause underneath the person who is dead. Then you'll also look on the left side. You'll notice that there's Roman numerals here. These show the generations of people. So if there's a Roman numeral 1, this is your first generation. If there's a Roman numeral 2, this is the second, and this is the third. The other thing that you can use to identify people is that in every generation, each person has a number going from left to right, and they have a 1, 2, 3. You start at 1 every time you go into a generation. So 1, 2, 3, and so on. And then you start at the next generation, you start at 1 again. So you can identify a person without names by calling them Generation 3, Person 2, for example, and that refers to this square. Okay, now the other thing about pedigrees is they finally assign a meaning to dominant and recessive, which is something that you guys have been hearing for more than a month. So dominant and recessive refer to whether or not a trait is present in every generation. So let's check this one out. Before you jump the gun, here's the thing. You have 2 couples starting this family. So since we have 2 couples starting this family, we need to kind of divide this in half, all right? And on the left half, we need to check, do we have a colored square at every generation? Yes, yes, no. So if it skips a generation, this is a recessive trait. The same is true for the other side. If we go to the other side, yes, yes, no. Nobody's colored in there. So that is a recessive trait. If you have, now in this one we don't need to divide it in half or anything because we have one couple starting up at the top. And this one's quite simple. Do we have at least one colored in square or circle in every generation? Yes, yes, yes. So this is dominant. Pretty easy. You can also see whether or not a trait is sex-linked or if it is equally affecting both genders. So in this pedigree, you'll notice, remember that squares are males, squares are dudes. So how many females do we see that are affected by this trait? Now, notice that these females have a dot in them. Okay, so if they're a dot, that's the equivalent of being half shaded in, which means that you don't have it, but you could pass it on to your kid. So they don't count. So all we see that are completely colored in are squares. 1, 2, 3. Because we have no circles that are completely colored in, this is a sex-linked trait, meaning if you're a male, you're more likely to get it. So this is sex-linked. You can tell a sex-linked trait if there's a vast difference of males being affected versus females. If it's like, 3 males and 4 females, then it's pretty even, right? But if you have, say, 16 males to 4 females, that's definitely a sex-linked trait.